This is August 26, 1981, a meeting of the American Chemical Society in New York is sponsoring a special symposium to honor the memory of R.B. Woodward. Among the participants at this symposium are four of Woodward's former collaborators: Ernest Wenkert from the University of California at San Diego, Jerome Burson, professor at Yale University, Dan Kemp, professor at MIT, and James Hendrickson, who is professor at Brandeis University. I'm Harry Wasserman from Yale University, and our association with Woodward spans a period of about 25 years of his career. I'd like to relate our association with him by describing a little bit of the period in which each of us was working with Woodward. I began graduate work at Harvard in 1941 at a time when Woodward was just made an instructor on the staff of the chemistry department. During the early weeks of September, he took two graduate students, Gilbert Small and myself, and I worked with him for 1 year, 1941 to 42, then left Harvard during World War II to go in the service, and came back at the end of 45 and finished in 48. During the period of the end of 1945 to 48, I completed my graduate work. Ernest, would you say a little bit about the time that you were associated with Woodward?
Sure. I was an undergraduate at the University of Washington in Seattle, hence far away from the East Coast. And I was advised to go to Harvard University by a recent young assistant professor who had arrived on the scene, who was a Harvard man by the name of Hip Dobbin. And as a consequence, when I came to Harvard, I chose what at that time was still a young but highly attractive professor, namely R.B. Woodward. My period of studentship spanned an interesting period because, as you yourself have just mentioned, there was a large group of veterans who had just come back from the war, whom Woodward knew very personally and directly as a young man, and then the group that included myself of totally new young people with wet behind the ears.
Jerry?
I had finished my graduate work in 1949 at Columbia, where I worked with Bill Doering, and I think it's interesting to note how the special quality that Woodward had was already manifest in certain circles at that time. Woodward was only 32 years old, and yet Doering was absolutely adamant about his instructions to me to do postdoctoral work with Woodward. He worked very hard at arranging this, and as matters turned out, it was possible to do that, but in order to accept a postdoctoral position with Woodward, I had to turn down an offer of an academic job, which sounds crazy in retrospect, and perhaps isn't done very often these days, particularly not by someone going to work with a 32-year-old associate professor, which is what Woodward was at that time. Nevertheless, I've never regretted it, and I think Doering's advice was absolutely correct.
Right. I just will add to my own experience that when I first came to Harvard, having graduated at MIT, I had planned to work with one of the senior members of the staff, Paul Bartlett or Louis Feser. Feser was doing war work, and Bartlett had just taken on a rather large group of students. Bartlett advised me at that time to seriously consider working with a young new faculty member down the hall before I made my final decision. So I walked down the hall to the old Chem 5 laboratory, and there I found a skinny young man wearing granny glasses, rolling his own cigarettes. And he outlined in the space of a few hours the synthesis of cantharidine, quinine, and cortisone, and estrone. And I then decided that he was the person I wanted to work for, despite the protestations of my friends at MIT, who advised me that I'd never get a job working with an unknown new person. Jim?
That's interesting. I'd gone out to Caltech as an undergraduate and had Linus Pauling for a freshman chemistry teacher, and I thought he was quite a fine teacher, but after that I didn't like many of my teachers. I'd gone to Caltech, I guess, because I'd seen something about Caltech in Life magazine. When I grew up in Toledo, Ohio, that's about all I knew about the outer world. And I'd also seen R.B. Woodward in Life magazine because he'd synthesized quinine. I was interested in organic chemistry in high school, and I went 4 years to Caltech, and there wasn't any real organic chemistry at all. I kept thinking, well, where is this quinine? I don't understand this. And so then I applied to Harvard for graduate school and went the first fall to Woodward's lectures, and there it was. And I suddenly remembered, yes, I remember his picture in Life magazine some years ago. So I was there as a graduate student from 1950 to 54. I went away for a year to do a postdoctoral fellowship with Derek Barton in London, and came back and did 2 postdoctoral years with Woodward. So I was actually on 3 different projects with him, and over a span of 51 to 57 before going to UCLA to teach.
Dan?
I arrived in 58 and left in 64. My arrival, the major project, I guess, was still the chlorophyll synthesis, which was in the process of completion. Woodward's group at that time was very large. It was spread over many floors and in several buildings. It wasn't easy, I remember, to get in to see him. And he really discouraged, initially at least, graduate students even approaching his group. But a number of us persisted. And after some months of trying to make an appointment with him, he arranged that we spend not 1, but 2 6-hour evenings in his office, in the course of which he outlined 15 or so research problems that ranged in scope from classical natural product problems to orienting peptide and protein molecules on electrode surfaces. And I well remember how, after the first of those evenings, I emerged unimaginably weary, with a feeling that the entire world of chemistry that I knew, and a great deal that I did not, had passed in one continuous session. All of us were dog-tired, but he, of course, was perfectly refreshed at 12 midnight or whenever, and quite prepared to go on talking.
Well, the sessions that are taking place this week have had as their emphasis Woodward's contribution to organic chemistry, the many aspects of organic chemistry which he was able to influence. What we would like to discuss this afternoon is another aspect of Woodward's impact on science, and that is his impact as a teacher. And I'd like Dan Kemp to start this discussion with some observations on this subject.
I think one starts with a paradox. To many of Woodward's colleagues, it was irritating that he did almost no formal coursework or instruction. He was not interested in classroom teaching. And yet, I think for any of his associates, he had to rank as the greatest teacher that they knew. The paradox, I think, is resolved if one thinks a little about teaching. It moves in 2 levels. I think one level is concerned with formal transmittal of information, facts, techniques. But there's another deeper level where one communicates what's valuable. And that, I think, is of much greater permanence and really greater importance, and that's where his great contribution as a teacher lay. In fact, the paradox is resolved when one reflects that one of the things that he taught is that if anything is worth doing at all, it should be done as passionately and as intensely, as intelligently as one possibly could. And what he abhorred, I think, about classroom teaching is that because it occurred daily or frequently, one didn't have the time to hone and to reflect, to create the epitome of the subject, to distill it forward, because certainly all who were fortunate enough to hear him lecture in a classroom situation on those rare occasions saw a masterpiece every time that he spoke. I think one other example for the time being will suffice of what he did as a teacher in terms of instilling value. Organic chemistry is an architectural subject. It hinges on structure. But I think not all its practitioners have seen structure as intensely as he did. And in fact, that's surely one of his lasting contributions. Many who first observed him drawing molecules on the blackboard felt there was affectation in the time and patience that he took to construct pictures of things. But as you sat there, watching these structures unfold, watching the care with which he presented them, you began to realize how important they were, how they were really something to be taken as seriously as anything in the subject. And I think similarly, if one ever got into an argument that depended upon examining a number of factors, one of the messages he taught very quickly was that you wrote them down patiently, carefully, you examined each one, weighted it, its due concern, and if it took 2 or 3 hours to do so, fine, that's the way to do it. Nothing casual. And I think that intensity was part of the key to it.
You could feel that intensity when he drew those structures. I mean, this idea of being affectation just wasn't, that wasn't it. When he put that chalk on the blackboard, the electricity would come out from it, and you could feel every carbon atom, and you could see and feel the relations between them, and that just drew you right in. If you were excited about the subject to begin with, this, it made it more important to have on.
You found, I'm sure in all our times, I mean, I surely remembered how graduate students and postdocs both would spend hours practicing.
Yes,
So that they could reach the point where they could, in honesty,
right.
present a structure themselves on the board in front of
Right.
R.B. Woodward.
Well, I'm sure that the beauty of his presentations at the blackboard was due to great care and a tremendous amount of practice on his own part. He took great pains before he gave a lecture to come very well prepared, even to the point of carrying with him his own kit. He would have his own colored chalk, cloth, white cloth to use as an eraser. Everything would be planned with great care. It was very deceptive because when he gave a lecture at the blackboard, it seemed as though the formulas just appeared there and covered the blackboard as though by chance, and yet it was clear that he had given very careful thought to this and had planned this out to the last detail. And this, of course, was representative of the way that he approached any problem. He absolutely left no stone unturned in analyzing a structural problem in the same way.
I would make an observation that perhaps hasn't been stressed, that concerns the ability of Woodward to teach in the course of writing a scientific paper. I think if you read the Woodward papers, particularly if you read the footnotes, there's a whole course in organic chemistry in those footnotes.
Yes. Yes.
There's one example that that I still use in teaching my courses. It concerns the synthesis of quinine, in which one of the last steps, in fact a crucial step, is the introduction of a vinyl group. Do you recall that? After the nitrite cleavage of that bicyclic compound, which leads to a precursor of the homomeroquinine, the introduction of the vinyl group is accomplished by an elimination reaction. And Woodward goes to great pains to tell you why the whole synthesis was constructed in such a way that the group to be eliminated was on the end carbon rather than on the center carbon. Because if it had been in the center carbon, the chances are very great that the double bond would have
the
gone
other
into
way.
the wrong
Yes,
position.
of course.
And that was all in one jewel-like footnote. You just read that and your eyes opened up for the first time. It was a marvelous quality. He did that repeatedly.
The terramycin structure proof strikes me as a perfect example of that. The paper was not so much to establish the structure per se as to show you, make you live the logic
Yeah.
as it evolved. And I can't help but think of a case in which he proposed an incorrect structure at a group seminar. He had been working on a molecule called streptonigrin. He had had an industrial group in his office presenting factual material. He had come up with a bold hypothesis that the material was bilaterally symmetrical. And there were not enough facts at the time to produce a structure. But he said, biogenetically this made sense. And so he called a special group seminar. It was in the dead of summer when the seminars tended not to meet. And so he was communicating his enthusiasm and the logic, even though, in fact, it turned out this was not a correct analysis. I mean, I think many thought him a person who carefully wove his presentations, so they put always the best foot forward. Well, here's a case where he really was putting the didactic content for the people in the class first, together with that chance to get the enthusiasm of the moment. I mean, here is it, the result, right from the office. In fact, I well remember he had gone into Kirby Scherer's laboratory and said the night before, you know, this proposed structure has a strained urea in it. What's its carbonyl absorption going to be? Now, if you were to go into the laboratory and make this biphenyl tonight, I'd be very pleased. And in the middle of a dramatic moment, he said, and we have this anomalous carbonyl. It's not like a urea, but of course structurally it's not a urea. And last night at 3 in the morning, I found Mr. Scherer in the laboratory, and lying on my desk at 9 was this result, and you see it's precisely in accord with expectations. that was, in a sense, the...
Okay.
Right. I think one of the things that might be pointed out on this occasion at a symposium where there is such an emphasis on synthetic organic chemistry is Woodward's contributions in the early days to structural elucidation of organic compounds at a time when he was able to bring this intellectual exercise to full fruition of the art. And I think that many of the students who studied with him learned chemistry in this process. The fact that he neglected no data, whether it was data from chemical degradation, from what spectroscopic data was available, everything had to fit. And he was willing to throw out conventional thinking and to start over if some of the facts
Yeah,
didn't
you know,
fit.
it's a curious thing that there seems to have been a fairly short period in his career in which he actually taught classroom teaching. Happens to have been, I mean, the time I was there, he mostly was doing that and giving this course in natural products. But of course, the course in the chemistry of natural products, as he gave it, was always, it was called selected topics, and it was always one subject, from which you start with one subject and then all of chemistry grows and flows from that subject. You really learn all of chemistry. You're not really just learning the chemistry of quinine or patchouli or something. But they were always exercises in the deduction of structure. And most of the chemists nowadays know that structure is not deduced anymore. It's simply produced for you by an X-ray machine. And this whole exercise in the logic of organic chemistry is largely faded from view. It was one of the most exciting parts of organic chemistry in those days and is no longer available. And yet, the building of the logic, the clarity and the brilliance and the excitement of creating the logic of deducing structure just by, in effect, mental application to some experimental facts he practically invented that exercise.
Well, I think that was-
Robinson used to be very good at it,
Yes.
but he guessed, you know, and Robinson would guess 2 or 3 times, and then when he was right, he'd forget the other 2 or 3, and he'd pick on the time when he was right. Woodward did it once and for all, because he went through the entire logic very carefully and made his presentation, and that was, in fact, the right answer.
And of course, the evening seminar was the format
Yes,
for
right.
this,
Sure.
in which problems were posed, and in a sense, the solutions, which were deemed inadequate or incorrect, were as effective a teaching tool.
Well, he encouraged
Yeah.
that.
Sure.
He encouraged,
He was-
Absolutely.
the format of his seminars was such that he encouraged individuals to go to the board and present prong structures. There was no penalty for doing it because he was able to show, to use us as a teaching aid.
Except in the mind of the presenter.
Only a humiliation, that was
Right.
The presenter found it
But it was-
difficult, but Woodward made it as comfortable for the presenter to
correct.
make a mistake
He
as
didn't-
anyone else
He
I
didn't
ever saw.
humiliate the
And-
students.
Right.
He was always extremely fair and courteous, but at the same time, always carried the didactic content forward as far as possible. I can well remember several points I learned at that point. 2 successive unstable or unlikely steps in a mechanism multiply together the probabilities.
Right.
And that was a point he made when he said this is otherwise acceptable, a plausible path, but you have to start with this high energy species and make something that is yet more unstable from it. And there was a little point, in a sense it was the Renaissance workshop style rather than the lecture style.
Right.
You
In
learn
fact,
by doing.
in fact, this one of the fascinating things about the seminars was not only the marvelous direct pedagogic appeal, because there you did do your deductive thinking, and you saw it delineated, even when you made a fool of yourself, but also the human touch, and in fact the human touch which at a later time certainly did me well in appreciating the scientific world, and that is that he made very, very clear that when he was attacking, that when he was in fact tearing something apart, it was a something, not the someone.
Yes,
And that's
absolutely.
one of the fascinating things was that this was a period of time when I think the scientific world had not yet realized that there's a difference, and there were rather vicious, almost sort of reminiscent to the rhetorics of the last part of the last century in the German literature. He made it very clear indeed that he was focusing on the chemistry and not on the chemist, and it really didn't make any difference. And as soon as you appreciated this, which invariably took at least a year or 2 years of graduate study, and you felt more comfortable, then you realized that even when you made a fool of yourself, no, you learned and the rest of the group learned.
Right. But
I
there
still
was-
remember a comment he made in a totally different connection in which a graduate student at my institution had discovered a rather brilliant point, but had made a gaffe in its presentation at a rather low level. And RB's comment was, but anyone can make that kind of mistake.
Yes.
Don't you really recognize that?
Right.
Absolutely.
I think the other aspect of this work on the structure of organic compounds was the way that he infused aesthetics into the exercise. When a structure was completed and he wrote it on the blackboard, there was this breathtaking quality of creativity. It was just as though he had created some beautiful work of art. And he, as Dan pointed out, he would take such great pains to draw the structure out carefully and to delineate the three-dimensional quality of it, just as though he were a sculptor creating something. And I think all his students picked up this feeling of appreciation, the feeling of aesthetics for organic chemistry.
I think that the business that Jim raised about structure determination being a lost art is certainly true at the professional level. I mean, one doesn't find most serious organic chemists spending a lot of time now determining structure. But the didactic value of this lives on, and the students recognize this. They instinctively turn to that. And my own group seminars, for example, we still have problems of that kind, and we handle them very much in the Woodward spirit.
Well, in fact, you know, it's rather amusing that in the field of synthetic organic chemistry, so the real strength of Woodward, very much the same type of thinking went by and still goes on. And that is that when, let's say, you have a highly polyfunctionalized molecule and you're carrying out a unique reaction at one spot, obviously the predictability of success is fairly low. And the consequence of which is you may get surprises. Well, the identification of the product, while now not the natural product, being truly a synthetic product, is identical in its analysis to what you would have in the other. And in fact,
Well, of course, xanthonic acid, which was mentioned in one of the lectures,
Absolutely,
there is such a
right.
thing. It's not a natural product. But
Absolutely.
I still remember a compound that needs figuring out.
Yeah.
Sure.
But still, there was a unique moment in chemical history when this wonderful gold mine or storehouse of classically derived structural information for the really hard natural products remained unresolved because the mechanistic thinking that R.B. provided and Robinson, of course, had started all came together with spectroscopic tools.
It lasted about probably from the late 1890s, I would say, from the time of Wagner and the terpene chemists until about 1959 or the end of the 1950s. And from there on, the subject just became fossilized.
And he was a perfect match for that age.
That's
I
right.
guess that's what continually amazes me.
The thing, you see, I think, Dan, that one of the things that contributed to the interest in that subject was the intrinsic interest of the molecules themselves, because people recognized that they were significant beyond their chemical structure. They were physiologically active, many of them, or they played a role in as Ernie has been a leader in allowing one to postulate mechanisms, and Jim has also participated in this work. Mechanisms about how natural molecules are formed. So there was a glamour associated with them that was beyond their mere chemistry.
Right.
But that now has, what is really the residue of that field now is what is called biosynthetic chemistry, or biosynthesis of natural products, where a lot of the work is now really at the enzymatic level, the really important scientific contribution.
Well, you know, there was another glamour, as you well know, in that same period that Roald Hoffman talked about this morning, that this was also a time when one really had some possibilities in application of theory to raising the chance that whole new classes of structures might turn out to be stable and interesting that were unsuspected. I mean, ferrocene is in a sense a pristine case of this. And I think part of the excitement, at least in my period, was on the one hand the natural product work you're talking about, these immensely important time-honored subjects, strychnine, which had been around for the history of the discipline, morphine similarly, steroids more recent, but still immensely valuable objects. But at the same time, cyclopentadienyl anion and tryptyllium ion and the possibility of homoaromaticity. Perhaps there is a whole new area of organic which can open up, which theory leads to. And I think at that moment there was a romanticism. I can still recall R.B. Chris Foote, of course, worked on a kind of a non-classical ion problem, and I can still remember R.B. calling a number of us together who were interested in that. He said, "I've finally figured what the cycloheptadienyl cation is going to turn out to be." And he drew a benzene ring with a methine, positively charged methine complex to it.
Sitting on the top like
Sitting on the
this,
top. He said, if you average all the Lewis structures, this is what you come up with.
The average stuff.
He said, that's what it's going to be. And that lent immense excitement, I think. Doors might open. And I think we don't have that right now.
It's interesting. What we're all probing, in a way, about his teaching is somehow how he conveyed to all of us, or at least turned on what was latent in all of us, a sense of this enormous excitement and artistic satisfaction that chemistry could provide if it was only done in the right way.
Right.
And somebody said the other day in one of the lectures, maybe it was Barton, in the old days, nobody used to think. The point was they just go to the bench and work and get results. And
Yes,
here was
yes,
Woodward telling you that chemistry, it was, one thing was what you did in the laboratory, but something else was how you thought about all these details and how the logic held them all together, and how when you saw all that, it was such a beautiful structure that it took on even aesthetic pleasure, which then was reflected in these beautiful drawings on the blackboard. And he'd go from the upper left-hand corner, as somebody said the other day in the introduction. Put all those structures on the board and finish at the lower right-hand corner just at the end of the hour. Which, of course, means that he had thought about the communication of all this very, very carefully.
Right. Along with this, of course, came his intense preoccupation with precision, with mastering all the details. More than anyone else that I know, he was able to concentrate on a problem and spend enormous amount of time analyzing the background of any problem. When I say enormous amounts of time, everybody who has been associated with him knows what his working habits were. But he constantly impressed his students with his knowledge of the literature. He was certainly the most widely read person that I know in organic chemistry, and he had a memory for all of these facts, which he was able to use very effectively.
And one of the most extraordinary things, incidentally, again, as a pedagogic tool, certainly left a deep impression on me, I think left a deep impression on science as a whole, is that through his reading and through his own innate curiosity about things, he was drawing upon, especially theory, but certainly practices of very, very different disciplines. I mean, the thing that actually cleanly delineated a differential and a breaking of the era from before him to since him is the fact that mechanistic reasoning, which, as a matter of fact, if you go to European universities, you even find in terms of a separate department, not just part of the same department, or you will find, let's say, in many international journals as a separate part of a journal, that mechanistic reasoning somehow or other was alien to a scene of where you wanted to construct something artfully. And what he really, what he appreciated right from the very beginning, and what he certainly taught to all of us, was that how horrifying it might have been to a young organic chemist, thermodynamics was a living thing, and kinetics was equally a living thing.
That's right.
And we might not have used a true K, and might never have actually run a full-blown experiment to get a rate or anything of this sort. We knew very well it was hidden in the type of statements that you made, and if you were in fact not partaking of that type of thought, you would make all types of faux pas. So that this notion of it being all of chemistry as focused upon a unique field, namely of how do you construct these horrendous molecules with all their beauty, etc., was something he brought across with immense pressure. And it's interesting that, in some ways, a shame that it took so many, many years until people really appreciated that this was the power of the field. The fact really was that for a young organic chemist to have become I mean, no one could become a Woodward, but to become, in fact, a truly outstanding organic chemist meant that he had to be knowledgeable in all these other areas, plus his own area of synthesis.
And yet with a hierarchy of standards. I think that's something that impressed me very much, that the experimental art was really foremost, a kind of a ground base, if you wish. Maybe there's a fluid obligato in the mechanistic thing that's all important, but still, I still remember asking him in my first graduate year, should I get elemental analyses on all of these new substances? And he looked at me and he said, if you make something that is a new substance, do it with courtesy of complete characterization.
And I think that's a point that's well worth emphasizing, that he made so many aspects of organic chemistry look easy. When he discussed a reaction, he moved arrows. He certainly was the father of the arrow-pushing aspect of
I would
organic chemistry.
interrupt to say that the people in England probably think that Sir Robert
Sir
Robinson
Robert, perhaps,
was
but at least in this
the
country. But underneath that, of course, was a very strong understanding of the theoretical aspects of organic chemistry. He had a very good understanding of physical organic chemistry, and many of the people who imitated him did so without really understanding
Well, in fact, let me
theory.
just tell you one experience I had, which really drew upon that with a vengeance. He once, during a seminar, presented a six-electron transfer reaction, cyclic transition state, and somebody had in fact written the arrows in quote the wrong direction, unquote. And we had spent about half an hour with him in the leadership of asking, well, does it matter? And it was a fascinating experience because there was no question whatever. The audience absolutely was biased that it didn't matter. And only through that type of discussion did we suddenly understand the formalism of it all and the much more serious significance of what our electrons all about, what our bonds all about, etc. And it was, it clearly showed that he was a teacher in order to use pedagogic tools and crutches and techniques and gimmicks and what have you, as everybody needs to, in order to pull the young student into it. But woe was that young student if he was left at the door where the deep significance of what he was doing was unlearned.
Right.
And he certainly managed to get them past that stage.
But along with that facility that he had in mechanistic and theoretical aspects of organic chemistry, as Dan pointed out, he never underestimated the importance of the experiment. And over and over again, he pointed out that organic chemistry is an experimental science. He would even go so
Point you
far
made
as
this morning, Jerry, about the quote that there are rarely sufficient excuses
For
to
not
do an
doing the
experiment.
experiment, yeah.
That's right.
and he would
Everybody must have heard that at some
Yeah.
time or another.
he would point out, perhaps a little facetiously, but I think he was convinced of it, that there are no general reactions, that every reaction has to be tested or tried on its own.
In that connection, I can't help but recall a conversation that Claude Wintner quoted to me once. Claude said to him, "You know, I think I now understand why you prefer synthesis and find it the highest art, because, you know, we sometimes talked about that as among graduate students. His research seminars focused so much on the mechanistic aspects. Rarely did one discuss synthetic strategy, for example, at them. And yet, his own bias was clearly that mechanism is extremely important, but the first love is synthesis." And Claude said, "Well, I think I now see that when you take a mixture melting point of two crystalline materials, one natural and one synthetic, all of the theories can blow away, but you're left with the fact that you did make it." And he said, exactly. He said, one basically has to be aware of what are the levels of proof, and that this is the absolute one. The theories, however much they're valuable, may or may not hold up. And I think the mechanistic studies he did, there was always that element of honest reservation.
But there is in every mechanistic study. You
That's
see,
it.
that's the characteristic of mechanistic
That's
study,
right.
and
That's
take
right.
it from a veteran in this area,
Sure.
that there's, no matter how carefully you think you've
That's
proven
right.
something, there's always somebody with another opinion.
Absolutely. Whereas
And
the
mixed
synthesis-
melting point, there's no argument.
That's right.
If you've got it, you've got it. And
That's right.
I can understand that absolutely, that sense of satisfaction that he must have had about closing the circle. No argument.
That's right.
Yes, that's true. But I think, you know, we can make lists about the qualities that he had and try to identify what the special features were about the way that he thought. But there was something else that made him what he was and made him unique. And I remember a particular case. It's a little bit awkward because I don't want to mention names here. It's a little bit embarrassing for some of the people involved in the story, so I'll make it anonymous as much as I can.
Let us guess.
This you can guess.
We'll guess afterwards.
This was during my, I went back to Harvard on sabbatical in 1959, so I had been away about 10 years, but the seminar was still going on as usual. And one night, one of the postdocs, who was in Woodward's group at that time, presented a seminar on some work he had done. He was a very good man, who a very well-known organic chemist today. And he had done this work in collaboration with an even better-known organic chemist. In fact, a very famous organic chemist. Perhaps Dan was at this seminar.
I certainly was. I remember it vividly.
Well, the seminar was a model of clarity and precision, and the work was presented in a very compelling style. And I think that at the end of the talk, which lasted an hour or so, the audience was quite convinced that that this group had correctly solved the structure of this rather complex natural product. Everything looked exactly right. The only thing missing was, as I recall, a total synthesis. But all of the information that needed to be obtained was obtained. There was careful spectroscopic examination of things
One
using...
biochemical quirk. It was biosynthetically anomalous.
But
that's
that
theory.
emerged only later, you see.
That's
Okay.
theory.
And at the end of the hour, there was applause for the speaker, a few desultory questions from the audience, and things seemed to be winding down. And it seemed to be time for Woodward to stand up and present what he usually did after the formal seminar, some special problem to engage the attention of the audience as a kind of dessert. But that didn't happen. And while everyone sat there in silence, one could see Woodward seated in the front row, smoking a cigarette and drawing structures on the paper, and it looked as though he was lost in thought. But what we didn't know was that he was still thinking about the seminar. And time passed, and I would say about 20 minutes went by.
Mm-hmm. He often did that.
People were talking about
Mhm.
the Red Sox or where they were going
Yeah.
to dinner the following night, all sorts of things. It was clear that there was no one in that room who had any question about the conclusions that had been presented to us except Woodward. And that didn't emerge until about, I think, a full half hour later, when he cleared his throat and said, I have a few questions to ask. And at that point, he stood up and drew on the blackboard an alternative structure for what had just been presented. One that he pointed out was biogenetically acceptable in contrast to the one that had been presented, which was not,
Yeah.
at least in terms of the biogenetic schemes that were being thought about at that time. And he said, I wonder if anything in all the evidence you have presented to us rules out the possibility that this structure, rather than the one that you've told us, is correct. And it was clear that the person who had presented the seminar had not thought about that structure. That had not been a subject of discussion. He made some honorable attempt to defend his own point of view, but in fact there was no distinction to be made based on the evidence at hand.
Well,
But-
and one other thing, that as I recall, there had been an acidic degradation in the original structure proof.
Yes.
And he even went to the point of saying that now the place where these differ has to do with the position of an alkyl group.
Exactly.
And you have used rather strong acid in this step.
And a rearrangement has taken
And a
place.
rearrangement could
Yeah.
easily have taken
That's
place,
right.
which would...
That's right. Well, as it turned out, of course, I tell you this story not for any trivial purpose. Woodward's structure was, in fact, correct,
That's right.
as was shown by subsequent experimentation. But the point I'm trying to make here is, you see that intensity of application, that feeling that what was going on at that seminar was truly important and merited one's deepest emotional concern.
Rather than just listening,
Rather
saying
than just
yes.
listen and say, yes, it sounds all very plausible.
Yeah.
Yes.
That is something that was unique to Woodward.
And
That,
that's-
and something that's even less definable, and that is the feeling that he must have had inside. And I assume that this was not just a staged operation, that he did not, in fact,
Have worked it all out.
have
I
worked it
don't
all out
think so.
beforehand.
I don't think
I'm
so.
assuming it was all on the up and up. And therefore, what must have, and it doesn't really matter whether he did or not, because even if he worked it out in advance, perhaps we didn't deserve the drama, but nevertheless, at some point, he must have said, there is something not quite right
Consistent.
here.
Yeah.
There's something that doesn't fit.
Right.
And he pursued that.
And it's important to get
and
it
it's
right. I
important
mean,
to get
there's
it
a
right.
lesson
Absolutely.
that he's
Yeah,
telling us
absolutely.
about.
That was a
It's
lesson.
the
Right.
importance
Yes,
of doing
indeed.
the work.
I
If you
think-
don't do it well,
In fact,
or don't do it at all.
Right.
Let me even comment on that, because I can vividly remember that. I was in my first graduate year. And in terms of educational content per second, that moment surely had reached some sort of maximum, because what this said to us was, here is this easy route. You follow what the speaker is telling you, and that isn't all that easy for a first-year graduate student
right.
to follow the logic of a talk. But here is a much rockier path, where you have to be thinking at each point of alternatives.
Yeah.
And that's what the real game is. And
That's
here's
right.
the evidence.
I think that aspect of his communication with other scientists is one which may not be evident in his published papers
That's
and
right.
in his symposia,
Very
because
true.
Woodward traveled a lot. He was constantly being consulted. He was so interested in organic chemistry that it was easy to discuss one's research with him. And every one of us probably knows of examples of contributions that Woodward has made to structure, to synthesis, to aspects of theory, which were simply based on exchange of information. He loved to talk about chemistry, and he was able to concentrate on the problem.
Actually, there was even a particular behavior pattern which he had, which, if misunderstood, could be unbelievably ego-squelching to you, and which, in fact, I think some weak personalities in the world probably have considered to be ego-squelching. And that had to do with the fact that he has, all his career, had such huge research groups that the probability was always exceedingly high that no matter what topic you might bring up, that he hadn't already done some bit of work somewhere in that area. So I remember coming to him on many an occasion when I came through Cambridge, and of course he wanted to know what I was doing at the time, and invariably what would happen would be after half an hour of chatting back and forth, he would say, "Ernie, wait a moment," and he would go to his outer office where he would have huge filing cabinets, and he would go through them a bit, and after a while come up with a little file. And before long, I discovered that 10 years earlier, he had obviously already done what I thought was fabulous work. And but what was very interesting about this was that you could turn this game around in the other way. That is, you could in fact appreciate that this was one of the things, one of his strengths, in fact, and rather than being squelched, actually learn something about chemistry, and thereby enrich your own chemistry.
I think, yeah.
This was something that was really very fascinating, because in fact the afternoon discussions, oftentimes slightly inebriating, because he was a great one of offering you drinks in his office, nevertheless were a tremendous give and take, and in the presence of yet other data that you knew nothing about, made it even more exciting.
You know, I think one can't leave the subject of his seminar without mentioning the other seminar, namely Saul Winstein's, that was happening at about the same time, and was also the tremendous didactic experience of a quite different sort. Winstein had the reputation for being able to memorize the speaker's numbers as they were being presented, to think about them as they were being offered, and then to feed them back to the speaker at the end of the talk in the form of questions, and woe to the person who was not sufficiently acquainted with his or her own data to be able to fend for themselves. I well remember being told by several people, Winstein saying to a rather distinguished chemist when he asked him a question and the man said, "I don't know," and he said, "Well, why don't you know?" And those two things together had similar flavors in the sense of intensity of thought and absolute integrity in terms of pushing the limits of thought and perspective right to the hilt. And they were certainly, I think, very close in terms of their own regard for each other.
I think
Perhaps
true.
for that reason.
And I think the other thing, now that you mentioned Winstein, and it might well be said that Woodward was very fond of sport. He loved to tease his colleagues and to tease his students. And
You mean non-athletic sport?
Anything but athletic sport, yes, all other sports.
He made a game. He really did make a game out of a chemical problem. His style in writing papers carried this even one step further. They were battles to be won. His co-workers
But
were
always fun.
Always, well, they were
Well,
challenges. They were a
yes,
gallant
yes,
band of
yes.
Swiss
Okay.
that were hurled at the barricades at the last minute in strychnine synthesis.
but that would be the ultimate
So that
fun
he
in case
he
one, wouldn't it?
infused his research and his research group with a spirit of drama. He had a wonderful feeling for the dramatic quality of a presentation. Not only was there a high order of aesthetics, but there was a timing and a drama to his presentations, such that one was always excited at hearing one of his lectures. And I think we're probably going to have to wind things up now. I don't know whether, I think there is another group waiting in the wings to talk about other aspects of Woodward's career. And so maybe we can summarize Woodward's contribution as a teacher by pointing out that the rigor of his thinking was something that every one of us carry away from an experience with him. Jerry, do you want to add any comments to summarize?
I would just summarize by saying he taught by example.
By example.
And his example was unparalleled. There was no second.
That's right.
That was how things should be done, and we all tried the best we can
That's right.
to reach that level.
So,